Hi everyone, how we doing? Oh, sorry about that. My name is Mr. Chavla, and in this video, I'm going to be going over the June 2016, sorry, Common Core Algebra 2 exam. And in this video, I'm going to be going over the key for questions number 9 through 16. Numbers 1 through 8, I just did in a previous video that's being uploaded to YouTube at this moment. And again, this is Mr. Chavla or Mr. C. My throat is clogged. Okay, let's go. We're going to start at number 9 in the June 2016 Algebra 2 Common Core exam. Number 9. Okay. The heights of women in the US are normally distributed with a mean of 64 inches. Mean is just an average. And a standard deviation of 2.75 inches. What percent of women to the nearest, okay, what percent of women will have heights between 64 and 69.5 inches round to the nearest whole percent or the nearest whole number percentage. So we need to know properties of the normal distribution. So I'll just write here that we have a normal distribution. Okay. Then we need to know mean is 64 inches. So this is the symbol for mean. Do you guys recognize this? And it's 64 inches. I won't write inches because everything is inches. Standard deviation is 2.75 inches. So the mean is the average. Standard deviation is the other statistic we're going to use in this problem. So I'm going to erase this so it doesn't block the text. Okay, now we want to know between these two values. So the lower is the smaller number in the range. When we're talking about what's between two values, the lower is actually happens to be the mean, and the other one is the upper is the higher value in the two. There we go again, me circling and ending up crossing out text. So I'll just highlight that again, and we got it. Okay, so now they want to know what percent would be between these two numbers. So in some calculators, you could actually just enter the values like this, the way I just did on the screen in some normal distribution calculator and get it like that. And so let me actually go to the Desmos graphing calculator and get the information for you. So you go to Desmos graphing calculator. You could easily find it by Googling. And then you'd scroll down, right? So the screen wouldn't start off looking like this. It would look something like this. I don't know exactly how it would look. But you would scroll over. Let me minimize me. You would scroll over whatever you need to do to get to, wow, to get this out. Here, let me Google it first. So I'll show you how I get there. Because I want you to be able to do this in case you don't have a calculator at home. So Desmos graphing calculator, it's useful for a lot of different things. Go to graphing calculator Desmos. And even though we're not using the graph feature, so since we're not, I'm going to just extend this so that I don't need to look at the graph. I'm going to enlarge this keyboard and go to functions. And then I'm going to DIST, which stands for distribution. And we want to look at normal distribution. Then if I look here on the left, I enter the mean first, followed by the standard deviation. See how it says mean, comma, standard deviation? Then I click on find normal, find cumulative probability, CDF, cumulative distribution function. I enter the minimum value, which in the range was 64, and then the upper value, the lower was 64, the upper was 69.5. I did something wrong. It was 2.75, not 65. Okay, and this gives me the probability, which is 0.47725 if I round it. And if I change that to a percentage, that's about 47.7% or 47.725%. That rounds to the nearest whole number, to the nearest whole percent, to 48%. Now, if you got that kind of feature in your calculator, that's awesome. And the easier you could get there, the better. And I'm going to come back up here in a second. But first, if you're using a TI, you're going to use, so if you look here, you see how it says normal, it says normal distribution, and then it says CDF or cumulative probability. It's something similar, but you're gonna have to know that you have to enter norm CDF, normal cumulative distribution function. Now I don't know how to get there because I haven't used the TI in ages. And then you enter the lower value first, which is 64. Then you enter the upper value. I'm sorry guys, I'm coughing so much today. 69.5. You follow that up. You enter the mean first. So you follow that up with the mean, 64, and then finally the standard deviation of 2.75. And if you put that in, you're going to get something similar to what we got in the calculator. That would be about 0.47725, which still rounds to 48% when you change the decimal to a percent and round to the nearest whole number. If you're using a Casio, so this was for TI 83, 84, if you're using a Casio, at least the type that we use in my school, what you're going to do is you're going to get normal distribution function, norm CD. This is the one I'm familiar with. It's just like the Casio. It's just like the TI. You're gonna enter the lower first, then the upper, but the difference is you're gonna enter the standard deviation before you enter the mean, and then you enter the mean last, which is 64. You do that, you're gonna get the same result. All right. So make sure you know how to do that. There are ways to also do this without a calculator, but since it's so handy here, we'll just use that, all right? There's some situations where you can't do it without the calculator. Pause the video if you need to. I'm going to move forward to question 10, and I'm going to erase this. Okay, so the formula below can be used to model which scenario? So I'm going to pull out the highlighter. We have A1 is our first term. AN is our current term. A of n minus 1 is our previous term. And to get each term, we multiply the one before it by 0.80. This is a classic recursive formula. You need to know the difference between a recursive formula, and let me come back here, and an explicit formula. This one has a first term of 3,000, and it has a common ratio where it's multiplying by 0.80 each time to get the next term. So it has to be a geometric sequence with a common ratio. So anything that doesn't have that, so I'm going to just go through each choice one by one, I'm going to eliminate. So in choice 1, the first row of a stadium has 3,000 seats. So A1 is the number of seats in the first row is 3,000. That is fine. Now if we look at the next part, each row thereafter, A of n, has 80 more seats. That's a plus 80 pattern than the row before it, which is A of n minus 1. That's not what we want. We want to multiply by 0.80, not add 80. Number 2. The last row of a stadium has 3,000 seats, and each row before it has 80 fewer seats than the row behind it. That's a minus 80 pattern. That's no good. These are both arithmetic sequences that have a common difference where you add or subtract. So 1 and 2 are out. We're already down to 50-50. Now let's look at choice 3. A bank account starts with a deposit of $3,000. So I would like to start at A0, but since that's not an option, let's say we start at A1, right? Maybe we start at A1, or is it A0? Then each year it grows by 80%. So it's 80% higher than whatever it was the year before. So to grow by 80%, you need to multiply not by 0.80. 80% as a decimal is 0.80. If you multiply by 0.80, you're actually going to end up reducing the value. It's 1 plus 0.80, 1.80. It's multiplying by 1.80 because it went up by 80% from what it was before. So this is a growth, and we don't want growth. Multiplying by less than 1 is a decay function. So it's not choice 3, and by elimination, it's choice 4. And let's just check out choice 4 real quick. The initial value, again, I'd prefer to start at A0 for initial, but let's say we go with it, and A1 is 3,000. The initial value is 3,000 of the toy. And the value each of the following years, AN, is 20% less than the year before. If it's 20% less, you start with 100%, you subtract 20%, you get 80%, which as a decimal is 0.80. So it retains 80% of its value, and that's what we got right here, is choice 4. Okay? Now, moving on to question 11. What you need to know about is recursive formulas, arithmetic and geometric sequences, and also modeling percent growth and decay. All right, so we're going to move on to question 4 now. Sean's team has a baseball game tomorrow. He pitches 50% of the time, he being Sean. So Sean pitches 50% of the games. There's a 40% chance of rain during the game tomorrow. And if the probability that it rains, given that Sean pitches, is 40%, what can we say about these two events? Okay, so first thing, we're going to say that we know that the probability, let me get this stuff out of the way. The probability of Sean pitching, I'll use S, is 50%, 0.50. The probability of rain, R, is 40%. Then the probability that it rains given that Sean pitches, rain, given, that's what this bar means, given that Sean pitches is also 40%. So what they want to know is, what can we say about these two events? So here's the deal, guys. Whenever the probability of an event A, given that B occurs, is just equal to the original probability of A, the two events are independent. Then A and B are independent. The same thing means that the probability of B given A is equal to the overall probability of B. Both of these go hand in hand. So the fact that we got the probability of rain given Sean pitching is just the overall probability of rain. They're both equal to 0.40. That means these two events are independent. Now, had they been different, it would have been dependent, that one changes the probability of the other. Mutually exclusive means they both exclude each other, and the probability of rain given Sean pitching would have had to been 0, meaning that they can't happen at the same time. Complements means that the probability that it rains given Sean pitches would have to be 0, and the two would have to add to 100%, meaning both of these would have to add to 100%. And the probability of Sean, the probability of rain given Sean pitching would have had to been 0, and the two events individually would have had to add to 100%, which was not the case either. So this is where you want to look up conditional probability. Answer is choice 1. You want to look up conditional probability. You want to look up independent and dependent events. And as a second hand thing, you want to look up mutually exclusive and complements. Okay, let's move forward to question 12. A solution of the equation 2x squared plus 3x plus 2 equals 0 is... So there are many features in the calculator you could use to solve this. I don't know what kind you're using. So I'm going to do this by hand and use the quadratic formula for now. So if you have an equation ax squared plus bx plus c equals 0, you use the quadratic formula, which goes something like this. X equals negative b plus and minus the square root, and it's given to you in the back of the reference table, the square root of b squared minus 4ac all over 2a. So our a value is the leading coefficient of x squared is just 2. Our b value, the leading coefficient of x, is 3. The c, the constant term, is 2. That's also our y-intercept. So if I substitute those values into the formula, negative b becomes negative 3. Plus and minus the square root, b is 3. We get 3 squared. Minus 4 times a, which is 2, times c, which is also 2. Then on the bottom we do 2 times a, which is 2. And when I simplify, what I'm going to get is negative 3 plus and minus. And on the bottom I get 4 when I multiply the 2 times 2, right? And I want to calculate what's known as the discriminant, the b squared minus 4ac part. I'll highlight that. I want to calculate this part. That's the discriminant. So let's go ahead and find out what that is first. So b squared minus 4ac, that's 3 squared minus 4 times 2 times 2. So we already put 3 squared in there, right? 3 squared is 9. 4 times 2 is 8 times 2 is 16. So it's negative 7. So this just turns into negative 7. Or you could have just put in the calculator the part under the square root sign. That's known as the discriminant. Now if you take the square root of negative 7, you get I. Now usually you're recommended to put the I before the square root sign. If you put the square root sign and you're careful not to put the I inside it, this is actually closer to the true a plus bi form we want. And the next thing we do is we just split the fraction into two parts, because we could split it into negative 3/4 plus and minus radical 7 I over 4. Now if you look at these choices, choice 1 is a candidate. We got an I in square root of 7. Choice 2 doesn't have the 7 in the square root, so that's out. Choice 3 doesn't have the I, so that's out. Choice 4 is clearly out, so by elimination we have 1. If we were to multiply I radical 7 by 1, taking choice 1, the solution would look like, and remember they said a solution, they didn't put both, so we could put plus minus to get both. It's negative 3/4. So if we just multiply by 1 on top here, it just becomes I radical 7 over 4. which is the same as this. So our answer is choice 1. And you could use whatever feature you want in your graphing calculator to confirm. I won't do that right now because I don't know what kind of calculator you use to get the roots. Okay, so make sure you know how to do that, and we could actually solve this one a lot quicker just knowing how to break it up, right? I'm going to move right along. You could also use, by the way, completing the square. I'm going to move along to question 13. All right, we're almost there. Sorry, guys, I needed space to do the next part. And then it doesn't make sense to have half written work written there now, okay? So pause the video if you need to. And then I will keep the fact that it was choice 1, okay? So now question 13. The Ferris wheel at the landmark Navy Pier in Chicago takes 7 minutes to make one full rotation. The height in feet is h above the ground of one of the cars can be modeled by h of t equals this whole thing right here, where it's a sine function, where t is the time in minutes. Using h of t for one full rotation, what's the car's minimum height? Guys, this is actually very easy. If you have an equation, f of x equals a times sine of bx plus c, and this is a horizontal translation, doesn't affect our solution at all. To get the minimum, all you have to do is c, that's the midline, minus the absolute value of a. So if we look at this, in our equation, h of t, our a value is 70, and our c value is 80. So if I want to do the c minus absolute value of a, that's 80 minus absolute value of 70. That's the min. And that will just give me 80 minus 70, which is 10 feet, is the minimum height in feet. And if I want the maximum, I would just do the c plus absolute value of a, which if you were to work out becomes 80 plus 70 is 150. And that's our max. All right, look that up. That's trigonometric functions, sine and cosine graphs, all right? Relating amplitude, which is the absolute value of a, to midline. This is amplitude, is absolute value of a, amp is amplitude, c is your midline, all right? So look that up if you need to. You could also use the calculator, but it's actually one of the few questions which are faster to do without it. Now I'm going to go on to question 14, okay? Pause the video if you need to. This is about trig functions, sine and cosine graphs, amplitude, midline. It's also a good idea to know about the period. So the expression 4x cubed plus 5x plus 10 over 2x plus 3 is equivalent to. So here's what I'm going to do, guys. I'm going to actually pull out my graphic calculator. I'm going to clear everything else out. And I'm still not going to use the graph, but I'm going to use the table feature. So if I set y1 equal to this function, 4x cubed plus 5x plus 10, all over 2x plus 3. I put the parentheses so that it doesn't divide, so it divides the whole trinomial. I'm going to get a table of values, right? And so I'm going to put a third column where I enter the table for y1, right? So if I want a table, I want x and I want y1 in this column. Now I'm going to just start at -5, go up to -4, and just keep going up to, let's say, 5, right? If I get one of the choices that keeps giving me the same output for the same x value, I know that answers my choice. So let's just do that first, and then we could either move on, or I'll go over how to do it algebraically as well, okay? For those of you who prefer that approach, which would have been necessary had it been a short answer response. But since it's multiple choice, we could just use the calculator. So let's go ahead and enter the choices one by one. So choice 1, y2 equals 2x squared plus 3x minus 7 plus 31 over 2x plus 3. You see how when I didn't use the parentheses, it only put the last term over there. So I'm going to look at y2 for the same x values. You can see they're not equal. They're not equal for when you input the same x value. So choice 1 is out. So I'm going to take that out of the table as well. I'm going to change y2 to be choice 2, which is what? Choice 2, which is, let me minimize me, guys, because I don't want to be in the way here. So 2x squared minus 3x plus 7 minus 11 over 2x plus 3. Now here, look at this, guys. It's a thing of beauty. When it's -5, we get the same y values. -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. And if you want to be extra confident, what you do is you add a third column. If they're truly equal, you don't want to look at all those decimals. You should get zeros down the line. If the two columns y1 and y2 are equal, you get zeros down the line. And let's also test for some random number. Let's say I'm just going to type something random in. I get 0 at the end. It's the same thing. And if I put negative, it's the same thing. So I got my answer, guys. And if you wanted to do that, that's a viable method to solve. And our answer is choice 2. Now, let's say you wanted to do this by hand. Here's what we need to do, guys. When writing the polynomial in standard form, you need to make sure that the exponents decrease by 1 at a time. So we have 4x to the third power. Then we have 5x, and that exponent is 1 plus 10. We don't have this x squared term, so to divide, we need to put x squared. We'll add a coefficient of 0 since that has no value, but we need it to divide. Then the 2x plus 3 comes out here. Now what we do is we follow the steps of divide, multiply, subtract. You take the first term, 4x cubed, divide by the first term here, and you're going to get 2x squared. And I'm going to check off at each time I complete a step because you're going to have to repeat. Then we multiply. We multiply 2x squared by each of these two terms. And when I do that, so as I multiply each term by 2x squared, I get 4x cubed plus 6x squared. So that's the multiplication part. Subtracting means I'm going to subtract whatever I got here. The sign is going to change to the opposite. So this will both become minus. If it was a plus, it would have changed to a minus, which was the case. Had it been a minus, it would have changed to a plus when we're subtracting a binomial. So the first two terms should cancel out. 0x squared minus 6x squared is negative 6x squared. So we got negative 6x squared, and I'm going to check off as we do each step. So now we're going to repeat. If you want to add another step, it's B for bring down, if appropriate, which it is in this case, plus 5x. Sometimes you need to bring down two terms, usually not. Now we're going to repeat. So divide, so this was one cycle, right? Divide this term, negative 6x squared, again, by 2x plus 3. I'm just writing it again so I don't run out of, so that I can underline it again. So we're going to divide negative 6x squared by 2x. That'll give us negative 3x. Now look at your choices, guys. None of these two have negative 3x, so that's out. This has a plus 3x, so this is out. And this is the only one that starts off as 2x squared minus 3x. So you could literally be like, okay, it's choice 2 and move on. But let's say we wanted to finish this off, right? You won't always be so lucky. So we took care of one division step. Now we're going to multiply this negative 3x, which I'll overline, by the entire binomial, which I'll circle. So negative 3x times 2x plus 3 will give you negative 6x squared minus 9x. Now, in the part where you subtract, right? I was doing that in green. So we did another multiplication cycle, red, right? We want to make sure you complete each cycle. Now when we subtract, that means both of these, because when I subtract, both of these will change to positive. So now when I do that, the negative 6x squared and 6x squared cancel out. 5x plus 9x is 14x. And then I go ahead and I bring down again the plus 10. Now I got one more step. I'm going to divide 14x by 2x to get 7. So I divided the 14x by 2x to get 7. Now I'm going to multiply the 7 by the 2x plus 3, and I get positive 14x plus 21. So that's one division, one multiplication, right? This will be the last step we do. Now we want to subtract, which means the 14x will become negative, and the 21 will also become negative. Right? And the more comfortable you get with this, the faster it gets, and you don't need to list them out like this. But we got this, so 14x is canceled, 10 minus 21 is negative 11. That's our remainder. Our final remainder goes on top. So I could either write plus negative 11 or minus 11, and whatever we're dividing by goes on the bottom. Since we can't divide it any farther, it's minus 11 divided by 2x plus 3. So we got 2x squared minus 3x plus 7 minus 11 over 2x plus 3, and our answer is choice 2. Okay, this is about dividing polynomials. This one was a little tricky, or using the calculator to use to find equivalent expressions. Okay, we're almost done. We're on the last two questions for this video. So let me erase this. Pause the video if you need to. so that we could get started with question number 15. So, which function represents exponential decay? Um, the fastest way to do this would be just to put all the functions in either graph or table, and the one that represents decay would be the decreasing graph. So let's actually do that first. Either we could use the graph or the table. Okay, let's cross all this stuff out. Let's do that first. So if I look at, so y1 will be choice 1, all right? y1 equals 2 to the 0.3x, because I'm not going to put t. You could see that's clearly an increasing function, right? I could even change the settings here. If I want to change the settings, you could see it's a growth function. Now, I'm trying to see something here, but it's not letting me do it. But we could see that's a growth function. There was something else I was trying to fix here. I'm going to reset the graph, all right, guys, because something got screwed up here. All right, whatever. I was trying to see the settings, like so I could set the window to the length I want to set it to. Here we go. This is all I was looking for. So I'm going to go from negative 10 to 10, and let's say negative 5 to, because exponential functions don't go above the x-axis, to let's say 30, and I'll just use a step of 2. So I'll go from negative 6 to 30. Since exponential functions never have, and I'll even start at negative 5, since exponential functions never typically go below the x-axis, at least not the ones we're looking at, but even if you don't set it, we could see from y1 equals 2 to the 0.3x, or 0.3x is clearly a growth function. Okay, that was not useful. I'm going to change this just to go from negative 10 to 10. Step 1, and from the x-axis we'll do the same thing, so we could see the growth and decay pattern. And we could see it's a growth function. It's not a fast growth, but it's a growth nonetheless. You could also use tables. Now I'm going to go and look at the next one. So y2, so that's growth. They wanted the one that's decay. So now we're going to look at y2 for choice 2 for decay to see if that's the one. It's 1.2 to the 3x or 3t. If you see, that grows actually faster than the previous one. So that's another growth function because the graph is increasing. You could also put it in a table, and you'd see that as the x values increase, so do the y values for choice 1 and 2. Now choice 3, we want to put 1/2 to the negative t power. So y3 equals 1/2 to the negative x power. That's also growth. So by elimination, our answer is choice 4, guys. And then I could show you guys quickly how that happens too. So if I do y4 equals 5 to the negative x, that's a decreasing function. It's decaying. As x goes up, y goes down. All right. There were other ways you could manipulate the exponents to get this as well, but I won't do that right now. Our answer is choice 4. The one thing you might want to keep in mind is that anytime all of these functions are basically a b to the kx power. So if you have b to the x, remember that because there's no a, right? B is greater than 0 means there's growth. I'm sorry, greater than 1 means there's growth, meaning it's an increasing function. If b is between 0 and 1, it's decay. But if you have a number in front, for b to a number times x, right? Power. If k is more than 0, the rules stay the same. However, if you raise to a negative exponent, the rules are reversed. Growth changes to decay, and decay changes to growth, because the powers are reversed, right? So 1/2 raised to a negative 1t was decay, so it becomes growth. I'll put that. 5 to the negative 1t becomes decay because it was initially growth. All right, and I won't go into the details that much because I don't want to take your time But there were ways to manipulate these exponents, and you could see that real quickly. But that was it for the first 15. Now we're going to do number 16, okay? That was exponential growth and decay function. So now number 15, given that f inverse x, this negative 1 on top is not an exponent, that means inverse. Given that f inverse x is equal to negative 3/4 x plus 2, which equation represents f of x? So guys, to find the inverse of a function, well, if you're given a function, typically you're asked to find the inverse. That is, you're given f of x, and you're asked what is f of inverse x. The great thing is that if you're given f inverse x, all you have to do is take the inverse of that, and you could get the original function. So it's nothing that tricky. So here's what we're going to do. We're just going to take the original function. What you do is you change it so it's written in terms of y. So the original function is negative 3/4 x. Let me rewrite that again. And we rewrite it in terms of y. Y equals negative 3/4 x plus 2. Then in the inverse, the two variables get reversed. So it becomes x equals negative 3/4 y plus 2. Now, none of those have that as an option, and they shouldn't. We need to solve this equation for x. So the first thing we're going to do is we're going to subtract 2 on both sides. And we get x minus 2 equals negative 3/4 y. Now you could either multiply by 4 and then divide by negative 3, or you could just multiply by the reciprocal. Multiply both sides of the equation by the reciprocal, where you flip the fraction and you multiply by negative 4/3 times x minus 2 equals y. And if I distribute the negative 4/3, I get negative 4/3 x minus 8 over 3. And you get y equals, but I'm going to replace y with f inverse x since we were using f of x notation. Or actually, we were given f inverse x, so we want f of x. So instead of y, I'm just going to write f of x equals negative 4/3 x minus 8 over 3. We'll write that nice and neat in slope-intercept form. Negative 4/3 x minus 8 over 3. I clearly did something wrong. Plus 8 over 3 because we are multiplying two negative numbers. When we distribute this negative over a negative, it becomes positive 8 over 3. So this is out, and it's choice 2. Negative 4/3 x plus 8 over 3. Thank goodness I caught my mistake. All right, guys, let me come say goodbye. For now, at least. All right, and I won't take this out of the way. Okay, I'll hang out down here. Can I say goodbye to you guys from down here? I think I'll be all right, okay? So, hope this helped. If it did, please hit like, subscribe. I'd appreciate that very much. And I appreciate your feedback. If you have any questions, let me know, and I will respond as soon as I possibly can. And I wish you the best of luck, all right? And if there's anything you need me to know, anything I could do differently, please feel free. All right? Best of luck, and I'll talk to you soon. Bye.